Alright guys, so now we are on chapter 2, lesson 3. You guys are doing awesome thus far. So, you should, like usual, in your Google Classroom, should have had some links to open up, so go ahead and open everything up. I think this one is just all on Amplify. But, so go ahead and open up Amplify so that we can do this together and make sure that we get it done A-okay and right on track. So if you opened up and it brought you here to the lesson brief, let's just go ahead and click on warm up. And here's your warm up. And so it says, in a moment you will rewatch the video, Mutations and New Traits. Before watching the video, list 1 or 2 questions you may have about mutations. Alternatively, you can list a few things you already know about mutations. So last night, for your homework, I had you guys watch a video. Some of you may have had a few complications, don't worry about it because I'm going to show you it again. But if you were able to watch it, I'm sure there were a lot of questions that you got. So go ahead and list them right here. After you list your questions, maybe list a few things that you do know about mutations. And if you don't know anything about mutations, that's okay too. Just, make sure you list all your questions. So go ahead and pause the video and do this warm up. Alright, so now let's go. You should have been able to pause the video and do warm up. You should have done. And then make sure you click hand in and next activity. Alright, so here is the video. I don't think it pops up on your screen. If not, go we're just gonna watch it right here anyways. So here we go.
This is a Scottish fold cat. Why do these cats have ears that fold when most cats' ears stick straight up? It started with a cat named Susie. Her parents both had normal ears, but Susie's ears folded over. Susie had a new trait because of a mutation to her genes when they were passed down from her parents. Each gene is an instruction to make a protein molecule with a specific structure. The structure of a protein molecule is important because it determines how it connects with other protein molecules. Interactions between protein molecules, like the way they connect to one another, determine an organism's traits. The mutation to Susie's genes changed the instructions for the cartilage her body makes. Cartilage is flexible, bone-like material. It's what gives ears their shape. The changed gene made a different protein molecule for the cartilage of Susie's ears. Now, the cartilage wasn't strong enough to hold up the ears anymore. So when Susie was born, she had the new folded ears trait. And that is how we got the first Scottish fold cat. Mutations are totally random, so there's no way of predicting which genes will be changed or what kind of effect they'll have. In fact, a mutation may not have any effect on an organism's traits. These two flowers look exactly the same, even though one has a mutation. But in Susie's case, the mutation did have an effect. This is how Susie got her famous ears. She passed this trait down to her offspring. We have Susie's mutation to thank for the Scottish fold cats we see today.
Alright, so we see that Susie's ears fold was actually a mutation. And this is where a lot of people, when they hear mutation, they think something is wrong, which technically, your genes are doing something wrong, but it doesn't mean it's something bad. Dimples are considered a mutation, colored eyes are considered a mutation, Spider-Man has a mutation, Wolverine has a mutation. So there's a lot of mutations that we might consider awesome or good, but there's also mutations that can be bad. So let's go ahead and go on to our next activity. And so here you guys, we are going to be working on a sim. And so we want to think about our investigation question, which is, why do some organisms make one type of protein for a feature and other organisms make two, right? So why even though it might be the same feature, why do we have different amounts of proteins? So we're going to look at this protein right here, and then we're talking about the bristles. So the bristle protein in example 1, this is our spider Annie. She makes one type of protein for the bristle feature. So you can see in her alleles, and you could see all right here, you see this little circle, and you can see, okay, so remember we've worked with these quite a bit during this, so remember the purple one is already there, and then she's producing these pink ones, so they show up. So these pink ones match up with the purple one, and then they go into the nucleus, and then they produce all of these bristles. But as you could see, she only has one type of pink protein, right? There's only one. So she is only producing one protein to make all these bristles. And so, I'm going to go ahead and make this go down. And now let's look at another one. And so the first image shows that Annie makes one protein, but now we're looking here at Sparse, and he makes all these bristles. And how many proteins do you see floating around in his cell? So the purple one's there, so those are the ones that we want to attach. And now you see a green circle and a blue circle. So inside of Sparse, we see two different types of pink proteins. You see right here, 1 and 2. So both of these proteins are producing bristles, but he needs two different types of proteins to produce his bristles, whereas Annie in the last one that we looked at only needed one. Sorry, guys. So, why do you think some organisms make one type of protein for a feature while other organisms make two? I want you guys to think about that. And we're going to have a Google discussion on it. So, if you want to write down your answer so that you have it to look back on, please feel free to do so. Okay, so now we're going to open up the sim, and let me go over the instructions really fast. So I know all of this says partners, and I apologize again, we are in distance learning, so we don't get to use partners that much. So what I want you to do is you are going to be partner A and B yourself. So you have to do all the work, but sometimes that can make things go faster, you know, so try to be positive about this. For partner A, you know, so I'm still going to say partner A and B even though it's just you. That way you know that there's two things that you have to get done. So for partner A, so for the first part, I want you to observe the cells for each spider. Find a spider that makes only one type of protein for your selected features. So remember in the sim, it has all the features at the top for the silk strength, the bristles, the color, I forgot the rest of them. We'll see them right now. So just pick one of them, and I want you to find a spider that only makes one type of protein, just like Annie did. And then partner B, so your second part that you have to do is, by observing the cells for each spider, find a spider that makes two types of proteins for your selected feature. So for the first spider and the second spider, you have to make sure that you're looking at the same feature. So in the first spider, if you're looking at the bristles, then the second spider, you also look at the bristles. If the first spider, you're looking at the silk strength, then or flexibility, then the second spider, you also need to look at the silk flexibility. So make sure you're looking at the same one. And then you're going to come down and you're going to record your results. So the feature you observed, the name of the spider that makes one type of protein, the name of the spider that makes two types of proteins, and then for number 5, it says in the space below, list ideas for why you think partner A's spider makes one type of protein while partner B's spider makes two. So you're just going to explain why you think one spider makes one protein and one spider makes two proteins. So let's go ahead and take a look at it. So let's go ahead and open the sim. You guys should be pretty familiar with this by now. If you're still having trouble with it, Please, please, please let me know so I can help you guys. I don't want this to be more difficult. I want science. Science is supposed to be fun. So if you're struggling, let me know, guys. So here's all your spiders. So up here at the top is the feature. Remember I said whatever feature you pick, you have to keep the same one for both spiders, okay? So you can do venom, bristle, size, body color, stripe color. Yeah, so just pick any one you want. I always, we all know that I always use Greg and Zora, our girl Zora over here. But pick any one you want. Remember, you just click on them, pick whichever one you want, and look at the proteins. Remember, we're looking at the pink proteins. So here, if we're looking at Silk's flexibility with Zora, we see that she is producing 2 types of protein for the Silk flexibility. Right, so you guys might want to use a piece of paper to write down your findings so that you don't get lost and confused, right? So I would just write down Zora equals 2 proteins for Silk flexibility. And then I will exit this part and go to Greg. Just looking at Silk flexibility. How many does Greg make? Oh, I only see 1 type of protein, so I'll put Greg equals 1 protein for Silk flexibility. And then you'll exit it, and then you'll check out another one. Okay, and you'll keep going, and then, but in your questions, remember, it wants you to only answer for 2 spiders. So if you look at all of them, that's awesome, but make sure you only compare 2. One that's producing 1 protein, and one that's producing 2 proteins. Let's go ahead and pause the video, and get that done. Alright, make sure you hit save and continue, and it should take you to number 2. And so now we're going to look at this again. We're still working on the sim. And sorry guys, sometimes my notes are a little off because it's for partners, and I'm trying to make this as easy and not complicated, being that we don't have partners. So now I want you guys, the next part that you're going to do is you're going to work by yourself to change your spider's genes so that both spiders produce the same proteins for the feature you selected. Discuss what changed and what you noticed. Use the discussion question below as guidance. What did you do to make spiders produce the same proteins? How did this change affect the spider's traits? And then you'll answer in the space below, describe what you did and observed in the sim. So you'll go in the sim, so you can, if you don't have it open up here, you can click on this again. I have mine open, so I'm just going to click on it. Now I'm going to use Zora and Greg like I always do, so I expect you guys not to use them because then that would be cheating. You're just copying what I did. So you're going to pick whatever spiders you want, or if you pick Zora and Greg, just don't do Silk flexibility, okay? You can do Silk stickiness or venom or stripe color, whatever. So here, Zora produces 2, right? I already remember that, so she's producing 2. But Greg is producing 1. So I need Greg to produce 2 as well, right? Because if I look at my instructions, it says, change your spider's genes so that both spiders produce the same proteins for the feature you selected. Okay, so he is producing the one that has 4 connectors. And what is Zora producing? Okay, so she doesn't have that one. So she has the stick. So she has protein 2 and 3. So I need her to produce the same protein that Greg is producing. So I'm going to go ahead and add a 1. So I'm going to glide it in here. So she's producing that. And so now, you see right over here, is something going to change? Now I got an asterisk, that means it changed. So my trait is medium still, right? And now it's back to normal. Oh, so it switched to medium because see, she's at high right now. So Zora's Silk flexibility, when I added a number 1 protein, because Greg produced that, when I added it, she went from a high Silk flexibility to a medium Silk flexibility. So and I'll do it again just so you can see it again. See, they're producing all right here. She's still at a high. A few more getting produced. A few more. Alright, she's not producing them anymore, but now they're floating around. Oh, and she changed to medium. Alright, so let's go see what happens to Greg when I make him produce what she produces. So Zora produces a 2 protein and a 3 protein, so I need to add both of those to Greg. So let's see if it'll let me. So here's a 2. So he's producing a 2 now. Remember, he was at a low flexibility. Alright, they're still producing. I'm going to add the 1 in there. And now he's at a medium after I added the 2. So now he's at a medium, and now the 3 is being produced. He went back to low. Oh, I forgot to add it. Okay, so here's this one. What happens when I add a 3 protein? So it looks like he still stayed at a low so far, so nothing much has happened. But when I added the 2, he moves up to a medium. So the only thing here is that I would suggest trying to find spiders that have a 1 protein and then 2 proteins. Try to, like Zora, as you saw, she already had 2 proteins. So let's go back to Zora real fast. She already had 2 proteins, and so when I had to add a 3rd one, it changed drastically. Remember, she went down to a medium, but when I went to Greg, I was unable to make him produce 3 at the same time. Okay, I can only add 1 at a time. So we don't know what would happen if he had all 3. So try to find ones that match. So maybe, so Greg here has the number 1 protein. So let's see if there's a spider that also has a number 1 protein. Oh, look, right there. This is Leo, and he has a number 1 protein and a number 2 protein. So they would be easier to compare. But now I'm going to come over here, and I would just write down what I did and what I observed, okay? And I want full sentences, so go ahead and pause the video and get this part 2 of activity 2 done. Okay. And then make sure you click hand in and next activity. So next activity is a second read of hemophilia article, and that one's going to be on another video. So go ahead and log off of this video and click play on the second YouTube video link that is in Google Classroom. Great job on your Sims, guys. Keep it up, and I'll see you in like 2.5 seconds.